Just going to wait for a moment for Maxwell. But other than that, the plan is to continue implementing Effect from scratch. Last week, we just did the A parameter, and we have a few more parameters to get to. But also let me know if you have any other questions, and I will check the Discord as well. Hey, Max.
Hello.
How's it going?
Pretty good.
Beautiful. We've got a few people here. I'm not sure. I think it's sharing on all the things. I think I sent out the invites correctly. See what happens. Do I sound okay? I'm not wearing... My headphones are dead, so hopefully that's not a problem.
At the moment, you sound good to me.
Good, good. Hello, Mattia. How's it going? Yeah, we can, I guess, just start in a few minutes, wait for a few more people to get to quorum, you know. And then, yeah, if anyone has any questions, feel free to throw them in the chat. But other than that, we can finish implementing Effect, you know?
All in a day's work.
Yeah, we're going to race. Whoever finishes it first, us in this stream or the entire team working on V4, that will be the next version. This one's probably not as efficient. Hello, Garboon. But yeah, let's, I don't know. Let's get started. It takes a while to get through this stuff sometimes. Just a brief recap. Last week, we implemented a very simplified implementation of Effect to understand how it works. We tried to break down Effect into various axes of power. And the first one that was encapsulated by the A type parameter, the success type parameter, was the ability to have laziness or deferred computations, to have descriptions or workflows of programs, which allows us to do some fancy things. So we saw basically how to implement this and then what kinds of features we could implement atop just this very basic core implementation of essentially wrapping a function a function of no arguments that simply returns some type. So we trap some value inside a thunk, as it's sometimes referred to, this nullery function value. So basically, yeah, we store off a function. That's what this primitive version of Effect is. We did implement generators, though we didn't talk too much about how it worked, or we had AI implement it at the end of last session. Don't really need to worry about that today, but we can now use with just this amount of code, use the syntax. And I think this might not work when we add more complicated error handling. So maybe we'll roll that back, but we'll see what happens. Okay.
Before we get into it, let me just check see if we have any questions. No, we don't. Okay.
Sorry?
I was just seeing if we have any questions. Before we get started, if there's any questions. I asked recently in the Discord about adding headers to an HTTP API error. Maybe one of you guys can give pointers. Let me open this question. How do I set a header on the error response from an HTTP API error .unauthorized? Want to add the www.authenticate header in my current middleware. I don't know off the top of my head. I have to look. So maybe we can continue with Kit with your stuff, and I'll look into this question.
Okay, cool. Let's see. Okay, cool. So anyway, sorry. We have a generator. Well, this might not work with the either stuff or the other things we'll be working with, but whatever. It worked for this simple example. So yeah, basically, we needed a way of, now that we've been able to wrap our effect up or construct effects by basically just storing a thunk. Now you can't just sequentially write programs as you would in normal direct style of just calling one function, calling the next function. So effect needs to make its own composition operators. And that's where you get things like map and FlatMap, for instance. But once we have this machinery, we can make some nice higher level methods like replicate, which takes some underlying effect and a number, and will return an effect that has that first effect run n times and returned as an array. So the implementation is pretty simple. We just call the underlying thunk, which is named run sync here, n times. And most importantly, so the primary power this gives you is that, yes, you can recall it. You can call because you know how you actually have a handle on the underlying computation. You can run it 0 or more times. So you can run it multiple times just because you want to run it multiple times. You can run it again because it's failed and you want to try again. You can also not run it until you're ready to run it, and therefore you can instrument an effect or do some around logic. So this allows us to implement timed, where we can get the date before we even run the effect and then run it, and then get the date after, the timestamp afterwards, and calculate how long it took to execute that effect. All things we talked about in the last session. If you want to watch the video, you cannot do with promise, because promise is stinky and is inherently limited by being not lazy and not storing the actual computation that it's a handle on. It just is a handle. It's just basically a little box that's going to get filled in with the result when it completes. But it's not in control of the running thing, actually. It can't cancel it. It's only going to get notified when that underlying computation that was kicked off at some point elsewhere is completed or fails. So it's very primitive, and it works in the simple case, but when you want to do fancier things, it becomes rather difficult. And you either have to just write all your APIs in terms of thunks of promises, which is kind of a little error prone and weird, or you can migrate to effect, and you can't really screw that up, and you get all the nice things for free and a whole bunch of built-in helpers. Okay, so yeah, we made some helper methods like logging and a random effect that basically just wraps a thunk of calling math.random. And then we saw we could compose these effects together. I think I have I have a way to run these tasks. Run task. Oh, what's this? Did they change? Oh no, I hit a shortcut here. Bun. Run with bun. Cool. Random number. Great. So we got we yielded random. We checked if it's even. We can switch the order of these, of course, if we want to. So we got 602, which is even. And then we called random 5 more times, logged it out, 5 more random numbers. And then we logged the initial n, which was 602. So we can compose things. And the nice thing about this is that we get something that is equivalent to async await. This is semantically equivalent to how async await works with promises, only it works with effects. And as we add other functionality, such as typed error handling, etc., it'll work with that as well. So it'll be more powerful than async await, but you don't need to know anything about how generator functions are implemented to use it, only to implement it yourself, I guess. You would have to know how generator functions work. But yeah, just treat it as syntax for sequential composition of effects that will short circuit if there's a failure. But we'll get to failures today. That's kind of the next step. But yeah, that's it so far. Hope that makes sense. Yeah. Okay. Cool. So let's add errors then. Probably want to make a simpler program for this. I'll comment this out. Maybe we'll come back to that later if we can add Effect.gen, but we'll see. So what I probably should have done last time as well was start with, instead of starting with the implementation, start with the ideal call site and then sort of reverse engineer the implementation. That might have been a little cleaner. So I'll try to do that today. And what I mean by that, it might have been nice to sort of have like, name equals effect.succeed kit. And I said, I want to make this compile. And this should be an effect of a string. And of course, in real effect, the type is nested under the module, but because we've implemented this a little differently, it is not. And we're doing it all in this file. Oh, I have to get the door. I'll be right back.
Gerboon, just to follow up on the question that you asked, I've pinged some folks in the Discord to see if we can get you an answer.
Okay, I am back. Did you are you answering his question, or do you want me to continue?
No, go ahead. I was just letting him know that I pinged some knowledge experts in the Discord that were not me.
Cool. Okay, so that would be probably a cleaner way of doing it, of showing the idea, the ideal sort of syntax, and then the ideal interpretation of that syntax, which would have been something like, and then when we run the name, result name, this should just be name result. This should just be a string, and we would have gotten this by calling name.runSync in our case. And then the challenge would have been to make this compile, which it already does. Console.log name result, because we did this yesterday. And there is my name up there. Oh my zeesh, can't update. That's annoying. Anyway, cool. So let's do the same thing today then, or take that approach with errors. So right now, we only have this single type parameter, which represents the successful outcome of our computation that we model with an effect. And so we would also want to be able to represent failure cases. So what might this look like? So there are a few constructors we can use. One is just effect.fail. So effect.fail. And we should be able to give it any value. So you could fail with a string, or whatever. Kit is deceased. That's a sad one. Kit has exploded. That could be possibly positive, if metaphorically speaking. So, and this is we can call it fail effect, or sort of, I can call it error, whatever. This does not compile at all. And this is going to get us back an effect of, it's not going to be an effective string because this first type parameter represents the success. In this case, using this constructor, we're actually going to know at the type level that the effect can never succeed. So the result type will be never. The success type will be never. And this is where we're going to need to add a second type parameter, which represents the type of the failure. So if this computation goes wrong, it's going to go wrong in this particular way. So that's what we need to model here. Cool. And then, of course, we need to think about, so this is just sort of, every time you define syntax or a sort of a programming language or a domain-specific language or really anything in programming, there are two sides, and neither side is really meaningful without the other. So you need both halves. You have syntax, and then you have semantics. So this is just how we define something, and the syntax in this case kind of also includes the typing rules. I don't exactly know where we want to say the typing rules live. I guess you could say that's on the right side of this arrow here. But anyway, we can consider for now just their syntax, and that syntax has nice types. But what does this mean? You don't know what this means until you give it semantics, and you give it semantics by interpreting. So interpretation. Interpretation. Did I spell that correctly? I did. So you in logic and sort of, what is it? In fancy computer science math terms, you often see things like introduction introduction and elimination rules. If you've ever sort of looked at lambda calculus papers for funsies, this is all sort of different ways of stating the same idea, which is that you have something which is just a structure, but then you need a way of interpreting that structure and running that structure, and how you run that structure. So structure and interpretation of that structure, executing it, is what gives it its meaning. So it's just like human language too, right? A word is meaningless until we interpret it by sort of mapping that set of characters to an idea, an image, a concept, and running it on our brains. Really, at the end of the day, how that word or idea or concept resonates emotionally in our heads. That's the real meaning of it. Anyway, so that's all to say. We need to run this, or at least explain what we want the semantics to be. So we have our error.runSync. It needs to have a runSync function. So what should happen? In the past, we sort of defined the semantics of log is that when you run sync, it's just going to execute the underlying thunk. And so when we execute log, well, it's going to print the message. Execute random, it's going to run random and return that number. Execute the name, it's going to simply, return the name that you've just packed into a thunk under the hood. In this case, when we want to run sync, we have to sort of make a decision. In this case, we probably want to, I guess, throw something. Yeah, we either need to throw something because we can't return never. Never cannot be constructed. It's a type with no inhabitants. There is no value never. It's just a type level label on a sort of an empty container of nothingness. So because we can't return never, we'll either have to throw, and we can't really throw a string. We have to throw something throwable. So we might have to throw maybe a special type, or we have to change the type of run sync to be something else entirely. Maybe we'll just throw for now, and we'll sort of wrap it up. So we'll expect some sort of like new runtime error, or sort of a effect runtime error of kit has exploded. If that makes sense. Okay. Yeah, that's one thing. Or we can actually change the result. I'm not sure which one would be better in our case. Maybe actually change it, because we're going to need a new type. Do you have any thoughts, Max?
Probably simpler to start with just throwing the error, and then we can introduce like a result type. But also important to point out that like in the actual like effect runtime, we do return like a result type that packs up like success and failure into like. So maybe it is actually worth introducing like what a result type looks like.
I was thinking, should we just do either?
Let's use result, because in V4 it's result.
Okay, cool.
Yeah,
and that has like an okay and an error branch. Is that right?
I think that we stuck with succeed and fail. I think.
Okay, we'll do that for now, so that's totally fine. So actually what this will do, so new semantics, because we're adding, sometimes when you add features to your domain-specific language, if you're defining one such as this, you need to modify sort of the core primitive that you're representing, your denotation here, which is, in our case, a thunk of A. But now we're going to want to extend this, and it's going to force us to change a little bit of everything to be some result type. So we're going to need a type parameter called E, which is how we can fail. And then we're going to see something like this, where run sync is actually now going to return a result of EA. Now I've got to add...
Here it might be worth fixing E to never, and then...
Exactly, yes, perfect. So now succeed, we don't have to say never. Sync, we don't have to say never. These will just never fail.
Just so you know, in V4, it's... result is a union of success and failure, and we do keep it as like succeed and fail, just as you're explaining things. Like we same constructors as like what effect has, basically.
Okay. So I will make a new result type here, which I guess I can give yes an A and an E, but it's not going to be like this. It's going to be a tagged type. And I guess we could also give it never here. Why not? And this is either going to be sort of have some tag probably. Success value A, or did you say succeed or success?
I think it's called success. Is the name of the type is success, and then the other one is failure, I think.
Okay, perfect. So it's either a success or it's a failure.
Yeah.
And this seems to be sad. Expected type comes to return type of this signature. Yes, that's true. Do I need to do something here? I'm not sure.
I don't think so. I think we can let's just keep going.
Okay. Yeah. So in order to fix this, by the way, because I don't want to change run syncs semantics necessarily, but we do need to store this internally like this. We sort of need now, it could just could be called run, or I could just call it thunk, I guess, because I've been using that nomenclature. I'll call it just run. So we'll keep our run sync on the outside. And then we can sort of define run sync as calling run. I'm just going to go with this implementation. And otherwise, sort of, yes, make a new runtime error.
Kit, why is it worthwhile to have these like tags in our result type?
Yes. So otherwise, if we don't have these tags here, we will not be able to distinguish between the A and the E, because there could be a chance that you fail and succeed with a string, and that they have very different meanings. And if it's literally a union of string and string, this will collapse to just being string, and we won't be able to tell the intention. We won't be able to know that is a string a failure or a success. So you need to have a value that is discriminable, that you can discriminate upon, a discriminator as it's called, so that you can know, even if they're both strings, well, this is a success string, this is a success, this is a failure string. Yeah, I think
you actually did use those semantics in your implementation of run sync. Basically, to like you used the tag here to actually like I think it's because error is not necessarily a string.
Yeah, any. Or can I do unknown? Not that it really matters. No, I can't. Okay, any. Perfect. Yes, exactly. Well, the tab model did this, so I didn't even realize what I did. But yes, it is correct, and it should have done this. So yes, we have this sort of underlying run method that's going to, what?
I think your type error is just coming because on some of the static methods you haven't fixed the signature yet.
Okay. So it's just it's propagating up here. Okay. Cool. So yes, we have this underlying method that will return this result type, which we can match on and deal with the different cases of. But we might want this more convenient high-level operator that will just sort of translate into a failure. When we have run promise, it can fail the promise for us. We don't need to deal with the result anymore. And we can still call, I guess, this underlying run type, if run function, if we want to. But for now, we'll just keep run sync at the top, so we don't have to change our other methods that use them. Actually, we might have to change everything anyway. Let's just go through everything. Okay, so now, why is this sad? So succeed, type parameter might need to be constrained. Yeah, this is all very interesting.
Try just changing the return type here, like the value type. No, like wrap it in the success.
Oh my goodness! Of course. Duh.
Yeah.
Yes. So yes, we need to change everything, because now the underlying thing is not just a function that returns an A, but a tag here. We might want to also make, like const result equals success and failure or whatever. So we can have a nicer constructor if we feel like it. Yay. And now thunk won't quite work. We need to make a new thunk that wraps our thunk and wraps it in success. So yes, you have to do this. Implementing these kinds of libraries involve lots of unwrapping and rewrapping, so that it's ugly on the inside but beautiful on the outside. So the consumers don't need to think of all this wrapping that goes on. But you have to map everything into this underlying model that can represent that can sort of successfully underlie and subsume all of the functionality you want to expose from your library. Okay, gen might just completely break. I'm going to ignore this for now. I might just remove gen and we'll just go to FlatMaps, but we can implement it at the end or have AI implement it at the end. Okay, so now mapping. So now all of our sequential operations and other methods need to change to handle the fact that now effect might fail. So right now we're sort of getting run sync, but this is not just an A, this is a result of A now. So we have to do the same thing where we have to sort of say if result of A is a success, well then we can get the actual underlying value. I'll see why that's, just run, not run sync. Otherwise, well, we'll have to just actually, let's see. We in this case, actually, we can just return result of A. We could wrap it up again, but that's kind of pointless because we know this is a failure at this case, at this point. And we actually have to add signature to our type. Oh, sorry?
Yeah. No, I was just going to say, I think you have to update the type signature as well.
We have to update the type signature such that we're going to use the error type. I mean, maybe I should do AEB. I don't know how we want to order this. I don't know what effect does itself, but
we usually like do the type orders in parameter in order, like you do in ZO. So this is exactly what we do.
Okay,
just keep the type parameters in order.
And so, what's very interesting about this too is that this is constrained by the really nice thing about making generic types like this. I think. What is it? Phil Wadler? Is that Philip Wadler? Right. He has this paper called like Theorems for Free or something, which is that's a Haskell thing. It doesn't really matter, just name dropping stuff. But the cool thing you get when you have this very generic parametrically polymorphic code is you have guardrails on. So it might look a little confusing, but the implementation almost writes itself. There's only certain things you can do here. Like we cannot call result.failure and just pass in whatever we want. This isn't going to succeed because we've just returned an effect of B. This isn't going to type check, rather. And in fact, we need an effect of B E, but we've returned a B string. And we don't know what E is. It could be any type. So we have to get E from this effect. That's the only place E occurs in our input. So that's the only place we can actually have that E type. We cannot just constitute it out of nothingness because we don't know how to construct it, which is great. So that not only does that keep you, if you're going to manually write your code, on track, but it'll also keep the models on track because they can iterate a few times. Am I Z converted? I like Z. It's fast. I think they did make an interesting bet because now I'm coding more and more with just Claude and OpenCode and Codex and all this, and I don't really type my code as much. I don't need all the fancy plugins that Cursor has, so it's nice to have something really fast to look at code with, and I just need some basic Vim editing, so I don't really miss the fact that it doesn't have all the plugins that VS Code supports, because I'm just prompting my way through life. Sad. But yeah. So that's how you do. Here we have to deal with the wrapping, and we're going to have to do something very similar here, which is, once again, so just good repetitions, add our new error type parameter. That's going to be introduced by whatever effect we're flat mapping. But in this case, it's actually interesting because we have a second effect, and we get to determine the semantics. So I'll start with something that we're not going to do, which is just to reuse the same E, but just to see what happens. And we'll get back to this in a moment. So now we're not going to call run. We're going to call, we're not going to call run sync. We're going to call run on the underlying effect. And then we sort of have to deal once again with these two cases. If it's a success, we want to do one thing. And if it's a failure, we want to do another. I think this might have screwed up its implementation here. But if it's a failure, we simply propagate this failure in the same case. So this is the short-circuiting semantics of flat mapping, of sequencing effects. If the first effect failed, which means we get an E and not an A, well, then we can't possibly continue because we can't call this function because we need an A and we don't have one. So we have to short-circuit, and we have to return an effect. luckily, it's an effect of E here, so we can fail with the E of the initial effect. Cool. Now, let's check the happy path here. So if it's a success, we can get the value out. Then we can call a function, which gets back an effect of B. And then, yes, we can just call run on that because that's going to get back a result of B or E, which is fine. However, this does type check and will work in various cases, but there is a problem with it, which is, I don't know if anyone wants to guess. I'm not sure if you can guess fast enough in the chat, but I don't even have water. I was going to take a pretend sip. Okay, so I'll spoil it. Yes, aha, Marcello, perfect. You can only chain effect with the same error type. So this E is going to become fixed. Or actually, I wonder what will happen. It might actually widen to infer that it's both of them. We can actually test this out really quick. Let's see what happens. There's going to be some limitation that's not ideal, but let's actually experiment. So we have error, we have string error, and then let's have a number error. Int or number. What am I doing? Int, Scala. Yeah, it's all number now. It's all floats. Okay, great. And so let's see what happens if we do a little bit of a FlatMap here. Program. This is a bad program, but let's see. String error. I think we still have pipe, right? No, we deleted pipe. So I'll say FlatMap, effect.flatmap. We're going to give it string error. And then we're going to give it a function that takes its result, which is never. So this will never be called, but whatever. I'll just call it A. And then we're going to call number error. And this should be okay. No, you're right. Yes.
Yeah, it doesn't auto-widen.
So it does not auto-widen in this case. I think there's some cases where it does, maybe if it's an object, but not. I guess it fixes. Scala has different semantics, which these are the subtle things I still have to completely memorize. But yes, so the E at the beginning here is going to be completely unconstrained. It's a type parameter. It's going to get, when you call it, it's going to get fixed to the first instance, the first concrete value that it's used for. So if we just passed in effect of never string, at this point, basically, which we did with our string error, at this point, when it's type checking, it's going to say, okay, well, now I know what A and E are. A is never, and E is string. And then when it goes to type check the second function, it's going to check to ensure that this E has to match this. But because it's not, because it's a number, that's going to be a type error and say, hey, number is not string, which is what this has become affixed to. I think we could fix this probably by, where'd I go? We could probably fix this by providing never, any never or something. Yeah, we can fix this by providing the type parameters here and explicitly widening the thing ahead of time to any, which is okay, but that's terrible. Obviously, that's terrible. What we really want is we want effect and the second effect to be able to return completely disparate errors. So I'm going to call it, I guess, E2. What do you guys do in the effect library? Is it E2 or E1? Doesn't really matter.
E1, E1, whatever feels right in the moment.
All right, I'll do E2 for now. So yeah, now the second effect can fail with its own error, which is can be completely unrelated, non-overlapping, or overlapping, whatever, with the original E. And so now we have to decide. The problem with this, it's nice that it fails. It's going to say something, whatever. It doesn't even really matter what that says, because now the return type can either fail with E or E2. And this should type check, but it didn't. So that's interesting. What have I done? I might need to... Is this a problem with my implementation of...
No, it's not a problem with the implementation. You just have to cast internally.
Shouldn't it be able to figure that? Is it maybe if I return result failure here, will that fix it? No, it doesn't. Okay, interesting.
It's because TypeScript it can't unify properly in this particular case.
What if I
So
do
we
the
actually
whole?
have.
No, it's not working. In out, no. It can't unify. Oh, that's interesting. Why not? Just because it's a nested function?
Yeah, I mean, we'd need like somebody with more like, mathematical brain to actually explain this, like Mike or something. But in this particular case, like TypeScript can't unify E and E2 because the second branch is only returning like E. So it gets confused about like what's going on here.
Boo. That makes me sad.
But
TypeScript.
tune in to learn about TypeScript limitations.
There we go. That works too.
You can either annotate it here or you can just cast on the return type, but it can't unify. That's why in Effect we actually have a little known helper for unification when TypeScript fails to be able to unify with like result types like this, like with Effect, like a parametric type that represents like a result. Sometimes TypeScript can't unify the types. So in Effect, we have this unification. I don't even know what to call it. It's like it's a unify module, and it has like a function you can wrap your functions in to make TypeScript unify things. And under the hood, it works with some type level trickery where like types can implement the unify trait. I forget the exact semantics, but if you look at, for example, the result type in Effect or Effect small or v4, whatever, you'll see like how some of these types will implement a unify like symbol, and we use that on the type level to like allow unify to work. So it's a little known thing, and we do use it internally in in some cases. But it can be used externally as well from the Unify module to deal with unification problems like this that TypeScript introduces. There was also another question, Kit, for you. Is it also the case that the map function is not allowed to introduce new types of errors?
That's true, yes. So because the map function doesn't return an effect in this case as a response, this is sort of like a pure mapping over the value of A. That's kind of the only difference between map and FlatMap, is that the result type is just a pure value instead of this wrapped effect. So we don't have a way of knowing what could fail in this function. So if you want to be able to specify a typed error, you would use FlatMap. Exactly. And yeah, I don't know what we do internally. It doesn't really matter so much as everything is thoroughly tested, but I definitely like annotating here, just because with cast, what we could accidentally do if we did do like an as or whatever, well, then we could accidentally do string here. Heisey? Hello. I meant to say effect B, E, or E2, etc. Oh, no, that's not right. It was be a result of B or E2, or maybe it's just something else entirely. Interesting. I don't know why that's failing, but that's okay because I prefer this anyway.
Yeah, I think and where we can, we avoid casts and we try to lean into like just manually typing the generics internally. But there are situations like when you drop down to the implementation. I mean, we're seeing this live right now with Kit working on this mock effect implementation, but there are situations inside the library code when you're doing stuff like this where you have to handle and deal with like the unsafety or the type not the lack of type safety because like when you're actually implementing the library code, oftentimes you have to do things that are not type safe to get things to work or to optimize like effects. Especially in V4, the runtime is very highly optimized, and there's a lot of things that need to be done and like drop out of type safety to be able to do that. So yeah.
Yeah, that still doesn't work. Yeah, so it would appear that I think this is probably a similar situation.
I think the reason why this is failing, by the way, is because what you get back is a union of result failure E, failure E2.
we get a result of B, E2, and then it doesn't know how to unify this into the right combination, which is interesting.
The other thing you could do is annotate the return type of the thunk. I'm not sure if that will work, but like you could do that as well. It has the same effect as just putting the type.
Yeah, B, E, or E2 should also work perfectly. Yeah. Yep. So that's interesting that it doesn't automatically unify, I guess, because it's in a thunk and it's far enough away from the type here that it's, there are various ways for it to unify. So, okay, not a huge deal at all, but good to know. We have to add that there just to help TypeScript out. Okay. And then in replicate.
We can invite Mike to the next office hours and have him tell us all about why TypeScript has this particular behavior from a mathematical perspective.
And so now here I will do the same thing. Effect E. Obviously, this effect is either going to succeed with an array of these errors or it'll short circuit and return the first one. So in this case, I can't quite do this anymore. I have to say result equals effect.run. And if it fails, then we'll just sort of short circuit with this. Otherwise, we'll have to return a result dot success. Push result dot value. Cool. So we just have to deal with the fact that this is always going to be this tagged union, tagged variant, some type, whatever you want to call it. And reckon with that in various ways. And now we can explicitly show that we short circuit here. So we have to also add these new semantics of short circuiting everywhere. Effect, this as well needs to say result.success of this. And we could also implement this in terms of, if we had gen, we could implement this in terms of gen and we would get this for free. So we don't need to actually go to the lowest level for all of these. Result A, but because I deleted gen and I don't feel like implementing this in terms of FlatMap, I can also just do this. We wouldn't have to corrupt every single combinator with the full knowledge of the lowest level representation of this result type. Once Effect.gen exists and can deal with that.
You may want to propagate the error type through from timed as well, like on this type signature level.
Oh, yes, of course. Okay, cool. So let's do this. Yeah. Otherwise, we could only run this with effects that succeed.
It is a very nice property of like you mentioned, though, these generic like polymorphic data types, that the contract that this is like type systems 101, but like when you look at the type signature of any of the effect combinators, like obviously they can sometimes get complicated with overloads and things like that. But if you just take a look at like the signature, oftentimes you can figure out what the semantics are just by looking at the signature. So it's kind of interesting to note that, like that, especially when looking at like that timed combinator, like the semantics before where like you could literally only pass in an effect that succeeds. Now we've like adjusted the semantics to allow you to pass in effects that fail as well. So it's just an interesting thing. I know you pointed it out before, but I'll point it out again. Like, I really like. I was going to say I really like implementing combinators for the effect library because you can like very easily control what the semantics or behavior of that combinator should be by just working on the type signature. And then the implementation sort of follows from the signature. So, yeah.
Interesting. I was expecting this to sort of figure out that if there was no failure and that this couldn't be a failure, but perhaps that would need to be something different here.
Yeah, you're still always going to get that structure back. So it can't figure out that like the failure case is impossible, because you could still get, theoretically, you could get a failure with a value that doesn't exist. Like it still gets the structure back. So you still have to discriminate in this case.
I feel like
TypeScript's
the
not
type
smart enough
system
to figure
should be
that.
able to know that.
You could adjust the signature of result to be like a conditional type, which like distributes over the value type. But again, like that's not really the purpose of a result type.
No, that makes sense. Yeah, still got to work on my TypeScript working memory. Or crystallized knowledge or what have you. Okay, so nonetheless, we've gone through and we've added this error type everywhere. Now we can actually use it. And so first of all, the type here is now correctly unioned. So it can fail with either a string or a number, which is really great that it can do this. And I could say like effect.succeed of 10 or whatever. And so now it can succeed with a number or fail with a string. So you just change your program and the type fully represents and honestly represents the possible runtime semantics, which is pretty great. And I love it so much. I love effect. So now if we run this, we'll see what will happen. So program.run sync. Yeah, we'll see what happens here. I've exploded. So that is indeed what's happening. It threw a effect runtime error. And if I just do run, well, now I'll have to sort of console.log this, and then we'll see it before a whole bunch of other nonsense because there's our tag failure. I've exploded. Great. Because I've also had the AI add effect.gen for us. So now we have effect.gen as well, and this will also work with failures. I think, no, it got the types wrong.
Yeah, the gen types are a little gnarly.
Yeah, to get that type safety with the gens, that's where it has to get a little funky. We'll see if it can fix it on the second pass. Probably not. Yeah, it's in interpreting the error type is any, so it needs to do something crazy. Oh, because it didn't even try. That's why it didn't get it right, because it didn't even
try. Classic.
It hard coded any. We'll see if it can fix it. Good luck. 3, 2, 1. Cool. So there's an inferring an E. Okay, sure. Yeah, I think that makes sense because the error type needs to come from the internal thing that it runs. Crazy stuff. Let's see if it works. Never. Good. And then in this risky program, bad luck. Indeed. That is the hard coded string literal type as the failure there, which is pretty great. Literal case. I want to add one more failure string literal case so we can see that it will also unify. So if we possibly fail with different error types here, well, here I'll just say whatever. If we still have random. If yield random greater than 0.5, effect.fail. Oops, and then we'll yield star this. And then I have to return yield. Oh, okay, no, it's sad. So yeah, it didn't do something. We'll always see any. Okay, it screwed something up. We'll see if it can do that. I'm wondering if this is now enough though to rewrite this in terms of effect.gen, in which case it would be nice because now we could just yield the effect that we've been passed and we don't have to worry about wrapping anything up. We could just sort of work at this higher level. And it does seem to type check at least, which is great. So yeah. So once you have effect.gen, you can write these higher level methods in a nicer way, including, which is so nice about TypeScript. So I sometimes, I'm still enamored with aspects of Scala, despite its permanent underclass status as a language, but it could not do this. So function star. Hopefully ours can. It might not either. What am I rewriting? I'm rewriting gen. I meant to be rewriting replicate. There we go. So anyway, I'll let it. I'll let it try to fix effect.gen one more time. or it's going to add a second failure type to risky, and then we'll get back to that last thing. Let's see if it succeeds or if this exposes another aspect of generator type inference woes. Yeah. Okay. It seems to work in this case. I don't know what I did that caused it to fail. Maybe conditionally failing, or maybe I just called something incorrectly. Yeah, good. So now risky program can fail with either bad luck or too high, depending, which is great. And these are both coming from two different method calls. Effect yields inside of a for loop inside of the effect generator function, which is just super cool that it can propagate all of these different error types from its body to its type signature and just have that infer perfectly. It's really nice. I'll keep saying that. I love it still after all these years of using effect systems. Cool. And now I can manually, as a human, rewrite replicate to now use Effect.gen. So we should be able to clean this up by not doing it at the lowest level, but calling Effect.gen as long as we spell everything correctly. And then, that's sad because, we don't need to deal with the failure case. All we need to do is say value or even A, and then we can yield our effect and then push the A. If we wanted to, you can just yield in any position. It's pretty crazy. And we don't need to wrap it in results. We just return the results. And that's just so amazing. And Gen helps with all the other complication, including short circuiting, etc. We can briefly peek at the implementation here. Obviously, the type signature, if you're not used to crazy type signatures, is pretty wacky. But yeah, basically, it's a generator that it takes some effect. That's what's going to get passed. This type is what's going to get passed to yield some effect. But because everything we yield might have a different error type and we want to consolidate them, well, we need to check if that error type does have an error channel. Then we want to infer it per call, and I guess use that. It's fascinating to me that this is able to unify and union all the types. What a crazy type system TypeScript has. But yeah, other than that, well, we kind of walked through this last time. I won't do that again. It's not. We should have another session sometime of just talking about how generator functions work, just because it could be fun. And I would like to understand the details of the types.
Its current implementation isn't going to properly distribute over the effect type. Like in the implementation of Gen, I don't think in every case this will properly distribute over the effect type in the return position. To get it to do that, you'd have to wrap. You'd have to do what we do with Gen in the library, which is take that F type and wrap it into an array. Not in that position, in the return position, and put an array around F, and then you'd have to check if that array of F extends an array of never, and return never if that's the case. Otherwise, you have to do a little bit more work to get unification to work 100% correctly here, but it got 80% of the way.
Yeah. Yeah. I've got to revisit my own tutorial website where I talked about or animated the distributive property of union types. But yes, definitely advanced stuff. Once again, don't need to understand it at all to use effect. And I hope implementing the other stuff just via flat mapping was clear. Okay. All right. So, that's basically the error type. I mean, it's pretty simple. We just have to now return this new tagged union that describes all possible outcomes, track that through, pull that through, thread that through at the type level, and add some extra unwrapping inside of our methods to deal with those possible failures.
I dropped a link in the chat for anybody who's curious about distributive conditional types and like why they're necessary in certain situations. And I can show really quickly if you want what we have to. It got like it really did get 80% of the way in this implementation of Gen, but to get the proper like distribution of errors and success like smushed into the final effect type, I think that's part of the reason why when you were yielding effect.fail, it was having an issue.
Are we like, what case would it fail? Because it seems to be working. I had it add a whole bunch of error cases. Like, it did seem to unify these two errors, but what did I do? I said something like, if yield, I'll just do math.random. Like, if math.random is less than 0.5, then I returned yield, because maybe it's a returning of a yield of effect.fail. .fail, oops, as const. Is this what exploded? Yes. So yeah, maybe, yeah, you can share your screen. Maybe this is the failure case. So just when it's in the final yield position, because otherwise, if we do this, no, that's still failing. It's pretty interesting. I don't know why. Maybe it's a direct fail here, because these are failing elsewhere, or they're returning effects that have a failure type. So it's very weird.
I stole the screen really quick.
Sure.
In our implementation of Gen, you can ignore the overloads here a little bit. You can also ignore this like yieldable type. This has to do with how yieldability works in Effect 4. Any type that implements this yieldable interface becomes yieldable in generators. So instead of having types that are subtypes of effect, instead we have types that are yieldable. But anyways, you can sort of ignore this and just take a look at the return type here, where in order to make sure that TypeScript can properly distribute over the error types, you need to use something called distributive conditional types, where we take the effect that the generator is working on, like this effect that is in the generator, and we use these bracket notations to. I can show what distributive conditional types are in a second, but we basically use it's a TypeScript feature where you can use this to get the proper behavior. So if we have a never in that we're extending here, we just return never. Otherwise, if we're extending a yieldable type, we can infer all the pieces of the yieldable type and return the one that we're interested in. Technically, these other infers I think are unnecessary, but this is the type that we're interested in inferring. And then we do the same. We haven't implemented this in our toy version of Effect, but we do the same for the requirements channel to basically make sure that the union of error cases and the union of requirements are properly inferred. And I can quickly, hang on, stop sharing. How do I bring the call back here? Share, screen, TypeScript, share. And I'll zoom in here as well. Who knew we were going to be doing TypeScript lessons today? But distributive conditional types are a feature of TypeScript. So like when you have a conditional type that's acting on a generic type, like we had in Gen, right? Like in this case, type2array has a generic type parameter of type. And there's some condition that you're doing here, right? You're doing some logic on the type to figure out what this type helper is going to return. So that's like called a conditional type, because you have a condition that will resolve the type for you. And when you do these types of conditional types, they become distributive when the input is a union. So like if this type was like string or number, then it distributes over that union. So it goes through each element of the union and does it. And the docs explain this, right? If we plug a union type into toArray, the conditional type gets applied to every single member of that union. So if we have string or number, this conditional type gets applied first to string, then it gets applied to number, and then we get the union of those results. So that's like when you have a basic conditional type, how it works. But in reality, what we probably want here is we want to have a string or number array, right? Like this type doesn't make a whole ton of sense. Maybe it does in certain scenarios, but I think probably what we want here is like string or number array. And so to achieve that, first we have to understand like what's going on here. So this kind of like breaks down what's actually happening. We get this as the input type. We map over. TypeScript basically does this internally. It maps, it applies toArray to each member of the union. And then you leave us with like the return type here. But if you want to distribute over that union, like if you don't want every member to be evaluated independently, if you want to distribute over the union, you have to do this like TypeScript trick, I'll call it, because I mean it's documented, but it's kind of like a weird little trick where if you put the type in brackets and you extend like also surrounded by brackets, like if you basically take this and just put these two things in brackets, then it will distribute over the union instead of applying the type to every member of the union. So instead of like this behavior, you get what we wanted originally, which is a string or number array. So to do and this happens when you have conditional types that work on generics, right? So like Effect has three generics. And if we go back to the example from before, really quickly, last thing, we go back here, we have a conditional type here, right? We're trying to figure out like what to do with the stuff that's happening in this generator. So we need to do conditional types to avoid distributing over the whole union of effects that are in this generator, because we could have like an effect that returns A and fails with Q. We could have an effect that returns B and fails with X, right? To avoid applying the conditional type to every element and instead distribute over those generics, we use the TypeScript trick here to make it work. Yeah. And the overloads here are just for the dual features of effect. So to make it, well, in this case, it's not dual. It's to allow us to take options. But you can pretty much ignore the overloads here and just focus on this first one to kind of understand what I'm talking about. So hopefully that made sense. I'll stop talking now.
Yeah, no, it is tricky. I was going to, yeah, I mean, I think we got the idea enough. I did actually. I'll share one thing, even though I don't. So I made this thing that you can go to types.kitlangton.com, and I have various little animations for TypeScript. So here's just one example where, like, you think of types as a label. I kind of referred to this before when I said never was a label on a box that had nothing inside of it. Like, you can think of a type as just as a label for a set of possible runtime values. So Boolean, there's no such thing as Boolean. It's just a concept, a label on a set of true and false. You'll never like have a runtime Boolean value, for instance. So you can switch through these things and see, okay, direction is would be a union of these four literal types. Number is a really big set going from negative infinity to positive infinity with infinity values in between. String, likewise, is infinite. You just keep adding another character. But never is an empty set, for instance. So there's nothing in it. There's no runtime value you're going to get. Any is all the values, etc. Anyway, so there's some various pretty graphic. But I do have something here for conditional types, which I think I kind of like. And sorry, I meant conditional unions. So when a union is evaluated, TypeScript processes each member individually and then unions the results together. This behavior is called distributivity. So if we say 42 extends string, then string, or else number, this is going to get you number because this sort of extends check is false. 42 does not extends string. So that's false. There's an example of this conditional type here, which is red extends string. Yes, therefore, it's going to return the first result. So it's kind of this type level ternary statement that's called conditional types, which is how you do branching in types. It's very interesting. And that's kind of where these conditional unions come into play. So if we instead had a union and we checked this, we made the same check, but instead now it's, instead of just 42 extends string, which is false and therefore returns number, we did 42 or 99. It's going to make the check individually per value. So you see sort of 42, it's making this check, getting a number. Now it's checking to see 42 and 99. And then it's going to union the results together, but number unioned with number is just numbers. So that's the final result. If we also add cat in here, well, cat does extend string, so that's going to be true, and that's going to therefore return string. So now our result set is number, number, and string, and these get unioned together as string or number. Same thing with dog, etc. But the unions sort of will collapse. They're sets of types, basically. So that's kind of how that works. And then if you don't want to get this union back, because like what if we wanted to know if, just sort of what Maxwell was saying, like what if we don't want a union as our result, just because a union was our input? That's kind of unexpected. You don't really, like looking at this type, you might sort of naively think, well, neither of my two return values here are unions, so I would never want a union. How am I getting a union out? Well, you can prevent that, but you have to wrap everything in arrays, which prevents things from unioning, which is called conditional non-distribution, if you want to disable that distributive property. And so here I have some various helpers. So wrap an array, takes a type, wraps it in an array, and then if it extends unknown, then it's going to return a type of that t. Well, actually, I'm not sure if I've, let's see what this does. So, so wrap an array, this is an actual value. We're given a type and a union type here. We want it to actually be, we don't want it to be a union of two different arrays. We don't want it to be string array or number array. We want it to be an array of the union of string or number. So if we didn't wrap it with an array here and here, then it would have been the opposite. I should probably show that variation. Oh, I do. Great. So if we don't, the only difference between these two examples is that the broken version does not wrap each of these arguments in arrays, and therefore we get this unexpected union of array types when we really wanted to have this helper type helper that wraps the t in an array, even if it's a union, instead of getting back unions of arrays, which would break probably what we're expecting. Anyway, there's a bunch of these examples you can walk through. I found that I basically built this for myself to understand, and then clearly slightly forgot how these rules work. And it's nice to have a visual representation to walk through. But yeah, there's a bunch of examples there. Check that out. $10.99. No, it's free. Where do I stop sharing? Stop sharing. Cool. Well, yeah, we added error types today. We could definitely, maybe next time, I guess the R parameter, if we're going parameter by parameter. There's a million details we can sort of nest into. I don't know if anyone, maybe we just finish it up with the R parameter and then just say that's done, unless people are really interested in something. Because there is the fact, in effect, that you can also have untyped errors, which we call defects. Effects can die, because of course anywhere in JavaScript code you can just throw, and therefore what are you supposed to do about that? We kind of skirted around that reality. So Effect does deal with that in a nice way, but we did not model that in our result type or deal with those failures. And we didn't implement any error handling either. So there's a few other things we could do, but we don't want to implement all of Effect. So let us know if you want us to keep doing this, or if you hate it. Comment, like, and subscribe, etc., etc.
Comment, like, subscribe, and follow, please.
Ooh, schema from scratch. That would be fun. Because
schema from scratch, man. You guys, it would be very interesting to take a look at schema v4, because in v4 the underlying types of schema have, I think we're up to 14 generic type parameters. So while schema from scratch would be extremely interesting, could be like a little bit challenging.
Well, we could probably just like we strip this down to one type parameter. We probably don't need
Schema
all the
for
type
category
parameters.
theorists.
Just to get an idea of.
I think, yeah, so the Urban asks, I'd like to know more about the fiber implementation. Yeah, I mean, there's lots of things we can do. So I guess drop your suggestions in the office hours channel and we'll try to get to all of them eventually. But yeah, like I hesitate on the schema one only because we'd be doing a lot of similar things. We'd be building an AST, because basically effect schema like represents the TypeScript type like as a runtime type with an AST. So we'd be building an AST, we'd be building an interpreter. It would be very like similar to what we've just done with effect. And it might be kind of interesting to look at some of the other aspects of the library. But anyway, drop the things that you're interested in discussing in the office hours channel because we're open to anything. I also think starting to take a look at topics for Effect v4 might be interesting for office hours, because I think we're getting very close. So it might be worthwhile for us to start looking at Effect v4 like migration topics and like other things that are interesting to note about v4. So anyway, yeah, let us know what you'd like to see.
Alrighty. Well, let's call it. See you guys next week.
Cheers, everybody.
Bye.